Hello everyone. Today topic database system architecture. In the last section, we have seen about introduction about databases and some terminologies for the database. In this session, we can start database system architecture. Here in the database system architecture, there are three important parts. One is storage management part, query processing part, and then transaction processing part. See this diagram, it will elaborate the overall structure of a database system. In this, the first part is there are different types of users with the database. Naive users, application users, sophisticated users, database administrator. Each of this user has their own type of interface to access the actual database. So this is the outer part layer where users are trying to access the database through their own tools or interfaces. And this is query processor part. Here the actual query get translated into machine understandable format. In here, it is a storage manager. In this part, transaction management occurs with authorization and integrity manager and other tasks. And this is your actual disk storage. In this, your actual data will be stored physically and their data dictionary will also exist. And this is the overall database design. We will see each and every part in detail. First thing is storage management. So it is an interface between the user and the actual data which is stored in the database. Here, the major process with the storage manager is they will make interaction with the file manager as well as it will allow you to retrieve, store, and update the data which is stored in the database. And major task with the storage management is storage access, file organization, indexing, and hashing. When you're storing the data, it has to be maintained efficiently with the proper structure. And if you want to access the data, proper hierarchy has to be mentioned like indexing and hashing techniques. File organization is nothing but first the index will be accessed and then the actual storage will be accessed to make it more efficient. So these are all the major tasks with the storage management. Then comes to query processing. Query processing has its own important steps like first, whenever the query is fed into query processor, it will be translated like parsing will be occur and then translation will be occur. What does mean by parsing? The query part will each and every term in the query will be converted into tokens and it will be translated into machine understandable form which can be set to be relational algebra expression. Once it is converted into RA form, then it get optimized. How it get optimized? By considering the statistical information which is already stored in the database, it get optimized to cost and memory. Then evaluation plan will be done. According to the plan, it get executed by the evaluation engine. From the data which is actually stored, the data get retrieved and then evaluation will be done based on the data. The output will be given to the query output. The three important steps with this parsing and then translation, optimization, and finally evaluation. So here, when you are converting the query, given query into different format, it can be in any type. It can be converted into relational algebra format, or otherwise it can be in any equivalent expression which the machine can understand. And then here the optimization is with respect to cost and memory. So when you are decreasing the amount of time which is taken, the query get optimized much. That is, it a good optimization. Whenever it takes more time, otherwise more memory, then it has to be optimized furthermore. So these are all the optimization criteria which has to be followed. So this is the part where query get converted into machine understandable form, and then evaluation will also get occur with the query processing part. Then transaction manager is a part of DBMS, like transaction management. When you take transaction manager, the term transaction is nothing but a collection of operation to perform certain task, a series of steps like getting the input, processing it, and getting the that is printing the output. Everything is a step in a single task. So the single task, when it has multiple series of steps, then it is said to be transaction. Transaction management component, like what is the reason of transaction management? Whenever certain operation is going on, if there is any interruption or failures, it has to be managed in an efficient way to overcome the inconsistency or loss of data. That is what the reason behind transaction management. Concurrency control manager is responsible for allowing more than one user to access the data without any conflicts. So whenever two different user accessing same data at the same time for updation, then the serializability has to be maintained to overcome the conflicts. That is the responsibility of concurrency control manager. There are different types of user we have listed in the diagram itself. Here, they are listed with their characteristics. Application programmers will access the database with the DML commands. Sophisticated user has their query access to the database. Specialized user, they will write their own query code to access the database. Naive user will take information or code from application programmers and then they will access the database. For example, naive users or like bank tellers, clerical staff, they have their task, but they don't have query or a code. They will take it from some other application programmer and then they will access the database. They are said to be naive users. These are all different types of database users with respect to database management system architecture. Then database admin. He has the overall coordination among all the activities in the database. He will know all the details about the database and the enterprise information which is stored in the database. And he has certain duties like storage structure and access method definition, schema and physical organization modification, granting users to the user authority and access to the user, backing up of data, monitoring performance and responding to changes, which is comes under database tuning. So whenever the user requests the database to access the data, first the user authentication has to be checked and the permission has to be given. Then whenever the user is updating the database, overall monitoring process will be done by admin. If there is any violation of rules, that has to be handled by database administrator. So these are all the major duties of database admin. It is also a part of DBMS. Here, there are different types of architecture in database. One is centralized client-server model, parallel and distributed. So centralized, there will be single database and all the users will be accessing the same database. Client server, like there is a server, the client will access the server and give the response. Server will handle the request and send to corresponding data center. That is what client server. Parallel, that is multiple processes and disk will be used. Here, it is not only one database center. There will be multiple database center, multiple processor. User can access any processor to conduct any data center. Then distributed. Here, the data will be divided into multiple parts and database will be in different parts. It will distributed around different area and you can access the data from wherever you need it, but the data stored will be in distributed and they will have coordination among the data updations and inquiries. This is what database architecture types. And here application architectures are two types. One is two-tier and another one is three-tier. In two-tier, there will be a single server and there will be a single client. The client will access the database through the database server. In three-tier architecture, there will be intermediate person. The user will have an application client as well. The database will have their application server. So the user will access the server through application client and then the server will contact the database center and give the request response to the user. This is said to be three-tier architecture. In that, the overall burden on the database will get reduced because if you are introducing a third layer in between, the burden on the database server will be reduced in three-tier architecture. Final topic for the first session is like history of database system. So in different eras, in different types of data storage mechanism have been used. For example, I am telling the different types of storage mechanism used in each and every period of time. In 1950s to 1960s, data tapes are used and punched cards are used for inputs. Between 60s to 70s, direct access is allowed with a hard disk. Hard disk came into existence and then network and hierarchical models are widespread used in that time. And here they have introduced relational model idea and they have been introduced by ACM and they have won award for the concept also. And IBM research begins with R system R prototype and Ignis prototype also invented by UC Berkeley. And then he this in this era high performance started doing like transaction processing have started with the high performance. Then in 90s 80s SQL becomes the industry standard and then relational prototypes are being used widely. Parallel and distributed databases came into existence. Object oriented database concepts also come into existence. In 1990s Here, data mining applications are invented, and then multi-terabyte data warehouses have been used here, and then web commerce concepts came into existence in the 1990s. By 2000, XML and XQuery standards are used. Automated database admins are used here. That is invented in this era. And then highly parallel databases are used. And then web scale distributed data storage have been widely spreadly used. So these are all the general introduction and that is various technologies and techniques with respect to database in different stages of timings have been mentioned here. So with this, I'm winding up the session, and we have completed the first session, introduction of database management system, till the architecture. And then next session, we will come with new topics. Thank you.